Hello dear students, welcome to chemistry class. In this class we are going to discuss about the valence bond theory. In short we can call this one as a VBT, valence bond theory, and it is actually the orbital concept of covalent bond. According to the definition of covalent bond, we are telling that the sharing of electron takes place between the combining atoms to form the bond. And here this theory will tell us how the sharing of electron takes place in the formation of an covalent bond. Therefore, it is called the orbital concept of covalent bond, and this theory was first proposed by Hitler and London in the year of 1927. First it was proposed by Hitler and London in the year of 1927. Then it is modified, further it is modified by the two scientists Pauling and Slater in the year of 1931. First it was introduced or proposed by Hitler and London, and later on this theory is modified by Pauling and Slater in the year of 1931. And this theory, VBT theory, explains the formation of covalent bond on the basis of overlapping of the atomic orbitals of the combining atoms and pairing of electrons which are present in that atomic orbitals with a opposite spin. Then now let me explain about the important features of valence bond theory. Here I am going to discuss some important features of valence bond theory, or we can call this one as the postulates of valence bond theory. Okay. The first one postulate or the important feature of this valence bond theory is a covalent bond can be formed by the overlap of atomic orbitals. The first one important feature or the postulate of valence bond theory is a covalent bond can be formed by the overlap of the atomic orbitals of the combining atoms. To form a covalent bond, the atomic orbitals of the combining atoms are overlapping each other. Overlapping means what? They are sharing an equal space. Overlapping. This hand is overlapping on this hand, means these two hands are sharing equal space. It is called out overlapping. Then the second one point is only half filled atomic orbitals with equal or nearly equal energy undergo overlapping. The next one important feature of this valence bond theory is while overlapping of the atomic orbitals, those orbitals which are half filled and also they are having equal or nearly equal energy will undergo overlapping. Okay. Then the third one postulates is in overlapping only the valence orbitals are involving and the inner orbitals are not disturbed at all. Okay. In overlapping process, only the valence orbitals are involving and the inner orbitals of those atoms are not involving. Means the outermost orbitals are participating in the overlapping process, but the inner orbitals are not taking part at all in the overlapping process. Then the fourth one is the electrons in the atomic orbitals involved in bond formation must have opposite spins. This is very, very important. The very important valence bond theory postulate is the electrons of the atomic orbitals which are undergoing in an overlapping or the bond formation should have or must have the opposite spin. Means one should have positive spin and another should have negative spin, plus half and minus half, like this, opposite spins. Okay. Then the next one important feature is on overlapping there will be maximum electron density in between two nuclei of the combining atoms. On overlapping, there will be a maximum electron density in between the nuclei of the combining atoms. When the two orbitals, valence orbitals of the atoms are undergoing in an overlapping, then at that time the electron density is very maximum in between the nuclei of those two combining atoms. And because of that only, and there exists, because of this maximum density of the electron in between the nuclei of the combining atoms, there exists an electrostatic force of attraction between nuclei and the electron cloud, which results in binding those two atoms. Okay, this is the fifth postulate. When the atomic orbitals are overlapping, then at that time there we can observe the maximum electron density in between the two nuclei, the nuclei of two atomic which are undergoing in an overlapping, and after that or because of that only there exists an electrostatic force of attraction between the nuclei of one atom and the electron cloud of another atom, and therefore it results in binding of those two atoms. This is a fifth postulate. And the sixth one is when the extent of overlapping is greater. When the extent of overlapping is greater, then the covalent bond formed is stronger. This tells that if the extent of overlapping is more, then the formed covalent bond is very strong. More the overlapping, higher will be the strength of that covalent bond. Then the seventh one postulate is overlapping along the axis, that is sigma bonding, is more stronger than the sideways, that is pi bonding, overlapping. This is the seventh postulate. Overlapping along the axis, that is the sigma bonding, means the axial overlapping, the head on overlapping is more stronger than the sideways overlapping. Sideways overlapping. This is head on overlapping and this one is sideways overlapping. This overlapping is more strong as compared to this one. Okay. These are all the important features, or we can say the postulates of valence bond theory. And now we have to discuss about the types of bonds, which is depending on the type of overlapping. Okay, depending on the type of overlapping, these covalent bonds are classified as sigma bonds and pi bonds. Okay. Then we know that there are two types of overlappings, means two ways are there for the atomic orbitals to overlap. One is head on overlap, then another one is sideways overlap. Then the sigma bond, which can be represented like this, is defined as the covalent bond formed by the overlapping of atomic orbitals along their axis. If the atomic orbitals are overlap along their axis, then the formed covalent bond is called what? Sigma bond. Sigma bond along the axis, or we can say end to end overlap or head on overlap. Then here again, depending on the type of orbital involved, these sigma bonds are classified as S sigma bond, SP sigma bond and PP sigma bond. Consider for SS overlapping, the SS overlapping or the SS sigma bond is the bond formed by the overlapping of two S orbitals. When the two S orbitals are overlap each other, this is the overlapping position. This results in the formation of an sigma bond, and that sigma bond is called SS sigma bond. Take for example the formation of H2 molecule. Here the one hydrogen which is having 1s1 electronic configuration will overlap with the another hydrogen which is having 1s1 electronic configuration, and here these two are sharing 1 electron each and forming H2 molecule. Then sp sigma bond is the bond formed by the overlapping of one s orbital with one p orbital, which results in the formation of an sp sigma bond. Here this s orbital will overlap with the p orbital along the axis. The p orbitals are having the axis x, y, z. X, y, z, correct? This is p orbital along x axis, p orbital along y axis, p orbital along z axis. Okay. Then here the px orbital is overlapping with the s orbital, which results in the formation of an sp sigma bond. Then for this we can take an example of hydrogen fluoride. In fluorine, in hydrogen the electronic configuration is 1s1, and in fluorine the valence cell electronic configuration is 2s2 2p5, and here on writing the p, 2 one unpaired orbital is there which can undergo in an overlapping with the half filled s orbital of hydrogen, which results in the formation of an sp sigma bond. Then the next one is pp sigma bond. Here two p orbitals are overlapping each other to form a sigma bond. For this I will take an example of formation of Cl2 or F2 molecule, and here the electronic configuration for this one is 1s2, 2s2, 2p5, and we will leave this one because only the valence orbitals are involving in a bond formation, that too valence cell is involving in a bond formation, that too the unpaired or half filled orbital s is completely filled, and in phi 3, 4, 5 only this p, px, py and pz is undergoing in a bond formation. This type 2 p orbitals are there, pz, which are overlapping axially, means head on, results in the formation of an pp sigma bond. And coming to the bond lengths of these sigma bonds, the bond lengths are there in the order of S sigma bond length is small as compared to Sp, which is small as compared to Pp, and bond strength is in reverse order, P, P, P. If the bond length is small and its strength is high, and here SS sigma bond is having small bond length, means its strength is high, because the s orbitals are spherical in shape and therefore they have short bond length and high bond strength. This is all about the sigma bond. Then coming to the second type of covalent bond, that is a pi bond, which can be represented with this symbol pi. This is a covalent bond formed by the overlapping of atomic orbitals sideways. The sideway overlapping is there, then it is called what? A pi bond. This is also called lateral overlapping. Sideways overlapping is also called what? A lateral overlapping, means sideways, lateral overlapping. For this only p, d and f orbitals will undergo the pi bond formation. For s it is not possible, and here I will explain the pi bond formation between the p orbitals, pp pi bond. Here this pi bond, which is having unpaired electron, will overlap with the another p orbital which is having one unpaired electron with opposite spin sideways, which results in the overlapping. This is a pp pi bond, pp pi bond. Okay. Then for this I will give an example of oxygen molecule, and its electronic configuration is 1s2, 2s2, 2p4, and here I will leave this one and I will write the electronic configuration for valence cell 4, and this is a 2s2 completely filled and it is of no use in overlapping, and this one is also completely filled, py, pz. Okay. Then here I will write the orbitals of py and pz only. Consider this one as a py and this one as a pz. These are the py and pz orbitals of oxygen, two oxygen atoms, and this py, which is having unpaired electrons of opposite spins, overlap along the axis, which results in the formation of an sigma bond, and this p orbital, that is a pz orbital, which is having unpaired electrons with opposite spin, overlap laterally or sideways, which results in the formation of an pi bond like this. This is a sigma bond, This is a pi bond and this one is a sigma bond, pp sigma bond. Okay, these are the some examples of pi bonds.